So my name is Jeremy Gray. I'm a cloud solution architect at Microsoft. I work in our financial services division with our regulated industries across insurance, banking, financial services, credit card, all kinds of fun stuff. I'm going to talk through today a real-world use case that me and my team have worked on in the past. This is a 20-minute conversation, so I'm not going to get a whole lot into the how. We're not going to get deep into a lot of things, but really what I want to talk about is the journey, the process, right? What was the thought process that we went through from start to finish to make this problem go from ideation into reality? So I'm going to talk about speech to text in the call center. So call centers are a thing that we all have. Lots and lots of signals that happen there. We like to think of them like this, where everybody's small and happy and we're all talking to each other. But in reality, from a data density standpoint and from a signals perspective, we're really packing a lot more into the situation than I think people would like to remember. There's lots of people going around. Some of them are yelling. Some of them are angry. How can I use that information to inform my business and make better decisions with respect to staffing and maybe call logs and marketing, things like that? So no matter how much money that we spend in these systems, sometimes it really still even feels like we're in the Stone Age. We put significant investments in our phones and our workflows and how that orients our business. But one really key area that we've ignored in the past are these transcriptions. And we've ignored them because it's hard. It's hard shipping a transcription off from an audio file to a human for that human to retype and send back to me. By the time I get that information, it's no longer valid. So today we're going to use, our goal today is to create a system in which we can unlock the value in those transcriptions and use them to inform our business. So the value that we see really is that humans can read faster than they can listen. For the most part, 3 times faster than they can listen, and that allows us to do lots of other things, which is reduce our agent handoff time. I don't have to ask my customer to relay their problem to me. I can read it on the screen before it comes up. I can use these systems for arbitration quality transcription. I can track customer sentiment throughout a call. That's something that I've never really been able to do before. Human transcriptions don't give it to me. And in general, when I look at kind of calls, it's onesie-twosie. I'm picking 1 out of 1,000 calls and doing some metrics on it. And we can do other things like Net Promoter Score, but really we want to throw a much wider net than that. Systems today should be working that way. And then we actually can use all of this information in aggregate to look at a couple things. Number one, the health of our business. What are people talking about? Did they start sad and end happy? Did they start happy and end sad, which is a much different thing? Are they all really kind of talking about something else that maybe I need to do a marketing campaign around to make my users a little bit better in our system? So this is really kind of the value that we want to add. And I like to start at the end. I like to say, what does a user look at? What's my end goal here? What do I actually want to do? So I want to create a screen that shows a conversation between a customer and an agent. And that screen will probably look a lot like this. And I want to say this is high transcription value and this is a medium confidence. I want to be able to click on a single utterance and I want that utterance to flow out through my microphone just in case that transcription isn't quite as good as I thought it was. Maybe they're on the phone in the car and there's a lot of road noise. So I get a low confidence transcription on the side and that would show up in red. Generally what we see when these transcriptions, when they actually run through, and I'm not going to talk about these cognitive services and transcriptions a whole lot, I'm going to talk about the process, but what we see is low confidence in single word utterances. Non-dictionary words, they bring our kind of transcription quality way down, but they don't really decrease from the message or the intent of what happened in the conversation. Really, really interesting. And then also here you can see on this side, we're tracking how happy and sad these people are. It's not quite that easy, but to really show the shape of this conversation, did your customer service agent stay at a pretty even sentiment across the whole thing, or did they show a dip in a certain point? Did the customer start happy and end sad? These are all really interesting, and we can also pull out key phrases and locations references. So this is what I want. This is, I think, the gold standard. This is a compelling visual screen that someone in a call center or management could look at, or in arbitration or in any kind of claims dispute could see and say, hey, this adds value to my organization. The speech to text is a cognitive service in our Azure Cognitive Service suite. It's that little guy down there in the bottom left. It's one of many cognitive services that we offer. We're not going to talk about that right now. I'm in the booth after this if you want to talk a little bit further. This is kind of an area that I can specialize in if you need me to. But for the intent of this discussion, we're just going to say that this is an API call. The thing happens. So let's look at some offline scenarios in this serverless world. And what I mean by offline there is when you hang up the phone, An audio file is created, it's dropped on us in some type of storage, and we're going to act on that audio file in the future. There is an online scenario. That online scenario is a direct integration into your phone system that exists. It's usually level 2, so I'm not going to go into it now because this is a little bit shorter conversation. So when I look at a problem like this, I really try to break down the workflow. And the workflow in almost every instance is pretty simple. I know what I want to do. I know the processing step here. I want to call this API. I want to do my transcription, but there's more work. And the first set of work is this pre-processing. Is there stuff that I have to do before I can actually send this file up? And then I can act on the file with my transcriptions and a processing step, and then I do some stuff in post-processing. This is pretty simple, and I find that 99% of problems that I come across in organizations really break down into these 3 steps. But adding detail to those steps, there can be lots and lots of stuff in there. So I'm going to start in general with a phone system. We just talked earlier, it drops out of some type of audio file, a WAV or an MP3, onto a file share somewhere, and then we're going to start a pre-processing. And adding detail into this pre-processing, I think is pretty interesting because you're working with an audio file. So what kind of pre-processing steps will we have to do there? Well, it depends, right? Just like everything else. But in general, when you look at phone systems, it's something that we bought 15 years ago. We configured and we just kind of let it ride and deal with it. So when we go in and look at these output files, a lot of times the gain is turned down really low, right? So we have to do some boosting. We have to do some signal boosting on these MP3s to actually make them transcribable. So we look at signals that are kind of short, -5 to 5 decibel gain, and we want to boost those up much higher so these transcription technologies can actually figure that as human speech and not white noise, right? So our pre-processing step in here is we're going to be acting on that MP3. We're going to be boosting that signal up so we can get a better transcription or more higher accuracy transcription out of it. Our processing step is pretty easy. We're going to take that processed file. We're going to send it to our Azure Cognitive Service. It's going to send me a transcript back in a JSON file. It's a computer-readable format. It's not a human-readable format. And I need to, guess what, use a post-processing step to convert that computer-readable into human-readable to get the pretty thing that I showed before. So I like to start this with an exercise I call a function with all the trimmings, or one with everything, right? I'm just going to take all of my discrete steps, I'm going to drop them into one box, and I'm going to look at it, and I'm going to get super uncomfortable about the thing. But when I do, it's a logical extension from step 1, 2, and 3. It gives me that ability to look at this holistic system and start to pull out pieces to distribute. So if we look at the pieces here, there's 3 of them. This boost signal, our pre-processing. Our Azure Cognitive Service, which is a lovely pseudocode shortening there, and then also our 2 HTML function. So those are the 3 distinct things that I need to manifest in such a way that to give me the output that I want. And hopefully all those will either go into an Azure function or something similar. So the first, so this works. This is something that you could do. There's some issues here. The most glaring issue and the first issue that I always look at in any kind of system is how do I deal with errors, right? My number 1 goal at work is to protect my Saturday. And dealing with errors is how you protect yourself from phone calls on Saturday. So the first thing that I want to do in this deal with errors is what happens if one of these things succeeds and one of them fails, right? I don't know because now my transaction is lost. So if I can drop a durable queue in between these 2 pieces and add a little bit of code, and if you want to talk about distributed messaging, grab me at the booth. I'm not going to talk about this in here. But we can peak lock this. We can remove the visibility of this thing off of the queue while we're doing the work on, and when the work is completed, we say, hey, this message is complete. The thing goes away and everything's fine. If we have an error, we can do the opposite. We can do a negative acknowledgement back to the queue and say, hey, this thing broke, and then kind of the sky's the limit on what you want to do there. So from an error perspective, this allows us to scale, right? So everything scales even in serverless, and it takes a little bit of time, sometimes more than others. And if you have 100 million transactions that come at once, we're really easy to keep them in queue while we're in a scaling operation on our serverless side to deplete that queue as necessary. So let's tease this out a little bit more. I've got 3 things in there. Let's look at the first one. So we're pretty sure that this boost signal is going to happen in a little bit different way. So let's look at this pre-processing step and assume that our almost everything else we're going to deal with later. How do we do this, right? Audio manipulation's hard. How do we take this MP3 file and transcribe it and change it in such a way that it makes sense? Number 1, don't go out and do it yourself. Find a library. Audio libraries are available out there in the world. There's lots of them. There's lots of good ones. The one that I want to talk about today is called FFmpeg. And this is it. This is as easy as it gets, right? We can do one single command line. We can take an input file, give it some parameters. In this case, it's boost the volume 150% and create an output file. This is great, but how do you do this? How does this work? Like, how do I actually get this guest executable, this precompiled third party, and drop it into any kind of framework? We're talking about a process start here. We're talking about moving things around. This specific library, if you put a higher level integration point or API on top of it, it's really becomes a licensing issue. So there's some legal issues around this. I'm seeing some smiles on there that people have probably been burned by this before. So using this in its native state is really the best, and doing a process start from inside a function, things start to get a little bit uncomfortable for me there. So when I'm in situations like this, I kind of stop, I'm looking at a single tree and I stop and refocus and look back at the force. Is there a different product? Is there a different way that I can do this? This process has to be run on compute, right? I have to use something VM-like in order to interact with this via the command line. So when you look around in the Azure platform, you see a product called Azure Batch. I don't like the name of this. This is in our HPC category. It's not in our serverless category, but this is effectively an ephemeral pool of compute. It's built on a VM scale set. It scales horizontally up and down based on the jobs that it has in place. We call this a job scheduler, but to me, this is an ephemeral pool of compute that I interact with an API. That's interesting. It's got an API. I can move into it. But there is a pool of compute, and it's separate. It's a separate process from the process that I'm working on today. This is what it looks like. If you pull it up in the Azure portal, this is a 5-node pool. This can scale up and down. These are just regular nodes. You can do low priority nodes and dedicated ones as well. We can talk about that at the booth later on if you'd like to. But this is interesting. So let's go down this path, right? Let's figure out kind of what boost signal would look like if I'm actually doing this HPC approach. So now our boost signal becomes, instead of pre-processing, now we're scheduling our pre-processing. We're delegating this task to a compute pool that's not in the memory space that we're in today. And here's kind of what some of the code would look like. We'll create a batch client, create a job, create a task. The task has a command line in it. You can see that's our FFmpeg input, output, boost 150%. Add that job to the client, and then monitor, right? So wait until the job is complete. So does this work? Yeah. Does this solve our problems? No, not really. I think there's 2 questions that you should ask. Number 1, does it work, right? And I think you can die on the hill of does it work, pretty easily. And the second is it serverless? Does it fit into this pattern, this distributed pattern that I'm trying to figure out? So there's 2 things here, right? There's a server. Is it serverless? I don't know. I'm not going to have that fight with you here. But that pool is managed. It moves up and down on its own. It's in a separate process. I can deal with that. I can get past that. But it also is polling. Can I get past the polling? Personally, no, I don't think I can. I'm still holding an open transaction on that function, waiting for a job to complete. That's a Saturday phone call for me. So what do we do? So is it serverless? The way that I've done it? Probably not. RIP, buddy. So the Grumpy Cat says no, this is not serverless. I can get past the managed compute, but maybe not in the polling. So what now, right? Like, what do we do now? We're in this place where we've gotten to the end of the logical thought process. We have a choice. We can move forward with looking with Azure Batch, or we can maybe look at a different approach. In general, I try to go down 3 to 4 different steps before I abandon a specific task. And so let's go a little further. Maybe there's an event. Maybe there's something that I can send it a task, and this batch pool or the job or task emits an event and says this thing is done. That would be great. That would solve my polling problem. And after you do a little bit of research, you're going to find something called a task complete event. But when we look into the documentation, this task complete event is listed as something called a metric. And what's a metric? Metrics for reporting. Is a metric a valid trigger for a downstream process? I don't know. Sometimes it could be, it couldn't. This is a smell, right? This is something, when you look at a metric, it's at least once deliverability. It's not guaranteed deliverability. It might be a delayed delivery. And if you look in the metrics, you look in the documentation for this Azure Complete event, you're going to see a lot of text, but I've highlighted the important part here that says, don't do this, right? If you read something like this in documentation, it's not a challenge. Don't do it. It's funny, it's loud, but I've been there, and I'm sure you all have too, especially you. So So what do we do? This would be sweet. This would be a really great, I think, answer to our problems, but it's not. It's not the answer. It's a Saturday phone call, and we're not doing it. So let's kind of go back to the drawing board and look at what our specific pre-processing is actually doing. And in this case, we have a gift, and the gift is that our pre-processing is file-based. And so we can, our HPC task, when it's completed, it can drop that output file into storage and emit the events that we need to, and our pre-processing is now complete. And we can move forward with our kind of do everything else. So our do everything else, now we have two more functions, or two more units of work that need to be pulled out into their own thing. These things are variations on a theme. We get it. We've got our cognitive services call, and we've got our to HTML call, and we need to do something with those. And the question becomes, do we use, what do we do? Do we split it into one function, or do we split it into two? How many functions do we have here? If we're going dogmatic, we've got two. There's a single responsibility in most serverless things. If we're doing pragmatic, the more serverless is more stuff. It's more builds, it's more artifacts, it's more management, it's more deployment, it's more risk all in all. It's more risk that I'm going to get called on Saturday. So these functions, splitting into two, there is a cost. Now in this shape, in this scenario, 2 is probably good. And why is 2 good? When I look at these two things, the shape of the compute in these two things is significantly different. We've got this call in this API that's going to be an open HTTP connection for a period of time. That's one thing, right? And then we've got this string manipulation that's this JSON to HTML manipulation. The shape of that transaction and string manipulation, much different, right? So in this case, the shapes of these things really, really indicate to me that this should be pulled out into into two separate functions. So our pre-processing is done. We've dropped our file onto here. We've got our processing is now complete, where we've got an Azure function that's calling it's calling the Azure Cognitive Service with a pointer to this MP3 file. The transcript is coming back in JSON. Our post-processing is now complete. We're taking that JSON file, we're doing some logic on it to make it pretty, and then we're storing that file. So this is great, lots of green check marks. Is it going to work? Give me some head shakes. Well, I'll give you a hint. There's 5 minutes left in my presentation. So here's what this looks like, kind of pulled out, the whole process. And I think at first glance this does work really well. But a question that I usually ask myself in the serverless world is, how long is this going to take? How long is this thing actually going to work? How long does transcription take? Does anybody know? I don't know. But I can only assume that the longer the audio file, the longer the transcription time. And there's going to be a point that at some length of audio file that I've kind of moved between a very fast, manageable HTTP connection to something that is really a long-running process. Look up long-running processes on the web in your own time. It's a lot of interesting stuff there. You read a lot about RPC. There's some other ways to do it, but the main function is RPC. So this is not going to work. Most organizations that you live in, if you have a transaction, an outgoing HTTP transaction open for more than 3 minutes, it's going to get whacked. It's going to get whacked for very legitimate security reasons, but it's going to get whacked. So what do we do? Once again, we're in this place. We're at the kind of the end of a logical. This isn't going to work. So let's look at kind of the overall solution and say, what do I have that I can reutilize? So if we look back at Azure Batch, we can put multiple tasks in here, right? Our pre-processing task can be chained to a call API task. It can be chained to a queue message task. And now all of my pre-processing and processing happens in that ephemeral compute. I got a long-running process that's happening in an area that's outside the memory space of what I'm in, and I get an event that gets emitted when the thing is done. That looks pretty good. And overall, this looks good to me, right? Like maybe it doesn't to you, and we can talk about that later on. But this is the I think this is the full workflow here. There's a lot of intricacy in here that we can deal with, but really that's not the point of what I want to talk about today. The point of what I want to talk about today is, what questions am I asking myself? How do I move from point A to point B with route regardless to the technology stack that I'm doing or the problem that I'm trying to solve? And these are some in general questions that I like to ask. Number one, errors. We talked about it. Protect Saturday. Where's the error? We just had a really interesting session on distributed monitoring. I haven't talked about monitoring at all. It's not because it's not important. It's because I only got 20 minutes. Is there human intervention when there's errors here? And who is that human? Is that you? And are you going to have to intervene on Saturday? Is there a rollback in this distributed transaction? I got really lucky here that I'm not adding $10 to this account and subtracting $10 to this account. So compensating transactions are a thing that you should think about in the future. You can avoid them if you can, because it's double the code, double the testing, double the builds, double the artifacts, double everything. How long does each step take? Are we moving into this long-running long-running process category? Are the compute shapes vastly different from each other? Am I doing file processing in the same place that I'm doing string manipulation? The last big one that I want to talk about in my last few minutes is how long do these transactions take, and how do I view them in flight? It's inevitable that somebody's going to hang up the phone, MP3 is going to get spooled out on this thing, it's a 4-hour conversation, and 3 minutes later you're going to start getting tickets that say, I don't see my call. I want to see this transcription. Something that was impossible for them 2 weeks ago that is now possible today. 5 minutes is too long to wait for. It's going to happen. It's going to get to you. So having some type of analytics dashboard to show these transactions in flight is a really good idea. I've used SignalR really, really effectively here before to show up a status screen and be like, well, look, your thing it's on step 2. It's transcribing right now. Go back to your desk. But in reality, by the time that ticket gets routed to you, the transcription is going to be available, and it's just going to be noise to you to say, hey, yeah, this is resolved. So give people tools in these distributed systems to see for themselves where their stuff is in the pipeline. Am I making something work in the way that it shouldn't? Am I shoving a round peg into a square hole? Idiomatic is the computer science word. Jeremy's rule of computer science number 3, which is starships are meant to fly. Don't make something do something that it's not supposed to do. And then finally, guest executables. We talked about that here today. This is a problem that's actually declining. We're not seeing as many guest executables as we used to see. I think the calm days are well, there's a long tail on that project, right? But we're getting there. So if you have questions for me, I'm at the end of my time. I'll be at the Microsoft booth inside the general session area from 10 to 2. Feel free to chat about any of this stuff. I'm Jeremy from Microsoft. Thanks for your attention.